Hello everybody, my name is Javier Burrieza and I am part of the technical coordination team of the Momentum project. Today I will introduce you to the research we are conducting in the project. Momentum project is an H2020 project that started in May 2019. It is conducted by a consortium of 12 partners, led by EMT Madrid. The overall goal of the project is to develop a set of techniques and tools for incorporating emerging mobility solutions in the transport planning tasks. The specific goals are to identify some future scenarios and challenges for transport planning in relation to emerging mobility solutions. We also characterize the changes in travel behavior brought about by these services. We develop some models and transport simulation tools for exploring future scenarios in how people adopt and use these new mobility concepts. And we improve the planning support tools to provide transport planners with solutions to cope with these new modes. Finally, once we demonstrate all the tools in the case studies of the project, we will provide some guidelines for the practical use of the new methods in other European cities. I'm going to explain to you which are the results we have obtained so far in the first stage of the project. In relation to the identification of challenges for transport techniques, we conducted some workshops and also Delphi Poll engaging different transport experts in Europe. We identify which are several alternative plausible scenarios for the evolution of European urban mobility. And to each of these scenarios, we explore which is the most probable evolution of the emerging mobility solution. Once we did that, we discussed with experts which are the requirements that the new data analytics methods and modeling tools in the transport sector will have to face if this evolution of emerging mobility solutions actually happen. In regard to the different techniques we are developing for analyzing new data sources, we are focusing on how to extract patterns from longitudinal data sets, such as mobile network data, mobility operation data, etc. One of here you can see two examples of methodologies we are developing. The first one is focused on the obtention of on the comparison of origin destination matrices. We are developing a similarity measure capable of compare different data sources to identify outliers in travel demand patterns due to special events, disruptions, or even also errors in the raw data, and also to identify early trends and clusters, which is something very important for instance, in the situation brought by the pandemic, to identify these trends and monitor travel demand patterns. Another example of a methodology we are developing is this estimation of representative origin destination matrices. Taking advantage of the clusters we can make with the similarity measure, we can obtain representative origin destination matrices for any kind of day. For instance, we can get a representative matrix for a working day and then use this matrix in the modeling tools. In relation to the research we are conducting about the adoption patterns of shared mobility services and other new technologies in transport, it is interesting how what we can see at the different case studies. We have observed a bias towards younger citizens, both in the household survey data and also in the operation data that some shared mobility providers have given us. And we can also see a bias towards highly educated population groups, something that is observed also in the available literature. And we can see also different patterns regarding gender. In relation to the use patterns, the characteristics of the trips performed by these new modes, we can see how they differ between car sharing, bike sharing, ride sharing. They have different profiles, but in any case, we can see how door-to-door trips are more common than multimodal trips. It's also interesting to see how in some circumstances the new modes can provide an alternative to private car. This was observed, for instance, in the Madrid case study in relation to the implementation of a restricted zone to private vehicles. We are moving now to exploiting all these results about data analytics to develop new modeling algorithms. We expect that the mix of the artificial intelligence approaches to exploit the historical data from the mobility services will allow us to identify which are the adoption and use patterns that can be incorporated to the modeling algorithms. This will enable us to develop more disaggregated approaches to transport modeling that have also stronger behavioral foundations. And this is also crucial for coping with the interaction between supply and demand. That is a feature we can find in this new mobility solution. In relation to next steps in the project, as I explained before, we will integrate all these advancements in decision support tools that will be provided to transport planners, and we will also produce some guidelines on the use of these tools. Some of the questions we are exploring in the demonstration of these new techniques in the case studies are which is the optimal design of public transport shared mobility intermodal hubs in the case of Lebanon. Another example is the experiments we are conducting in Madrid for simulating how emerging mobility solutions can play a role in peripheral areas rather than in central areas where they may compete with public transport. We will also look at how demand responsive transport services can improve sustainable mobility in the case of Thessaloniki. And another example is this aspect we are looking in Regensburg about to what extent mobility services can reduce car ownership levels. At the end, we are moving from a phase where the focus was on data analysis to the integration of these techniques in modeling algorithms and ultimately in decision support. About the key impacts of the project in a long-term perspective. First of all, in the science and technology domain, we will provide future research topics for this aspect. We will also provide new capabilities through these methods to analyze longitudinal data sets, and we will also improve the implementation of new technologies in the transport sector. In relation to innovation, we think that Momentum can have very strong contributions to the anticipation of barriers and drivers for the adoption of innovative solutions in the transport sector. We expect also that the data that is already passively collected will increase its added value by being able to exploit through the data analytics methods we are developing. And we think that these new techniques will improve the planning and management of shared mobility services, something that is very interesting because many providers are still facing many challenges in relation to profitability, right? So we think that this is also a very powerful aspect of the project. Finally, some of the companies that we are involved in the Momentum project, we are part of this ecosystem that is emerging around the intersection of data science and transport planning, and we think that it's also a new economic sector that can bring good economic profits for the European Union. Finally, in terms of society and planning, we think that this project will improve the resilience of transport planning strategies and will also allow us a better integration of emerging solutions in the transport system. And finally, will both reduce the costs of data collection methods, something that is very important in transport planning, while at the same time will support through the new visualization tools and so on, will support collaborative decision-making processes, something that is very important for engaging citizens in future scenarios for transport planning. That was all from my side. I hope that you enjoyed the presentation and the Congress, and I will be happy to engage in further discussion with you. Thank you very much.